a warm welcome to this session of the science faculty. I'm aware that we have parents in the audience who come from different provinces in the country, and that there are also parents who come from neighboring countries such as Botswana, Namibia, Zimbabwe. So a warm welcome to a very warm Cape Town. I wish I was welcoming you in person, but that's not possible at the moment. Just to remind you that you will not be able to use your mic, and please don't try to use the mic during the presentation. You will have the opportunity to ask questions at the end of these presentations, and that's when you can use the mic. I should thank you first for really thinking of UCT and the science faculty as a place where you could enroll your sons and daughters in 2022. We have been engaging them as our new students, showing them around the lecture theatres that they will attend, the classes, and also giving them information about their stay at UCT for the next 3 years. We did emphasize, and the team that was involved in the orientation is with me here. We did emphasize the point that they've got 3 years to complete this journey. And I hope that's what you would also emphasize when they come home after lectures, after tests, after exams, that this is a journey that they need to complete. I should also let you know that in the science faculty we receive many good applications for students who want to come and study with us, but we have got very limited space. So it is important for you to know that your daughters and sons have been very fortunate on a competitive basis to be admitted to the science faculty. We had to turn away many other applications, and these were also good applications, but we could not accommodate them because of limited spaces. And I'll come back to the issue of limited spaces when we talk about some of the courses that we offer and what those limitations are. In this day and age, whenever we talk about limited spaces, people think, well, if we have got virtual classes, if some of the things are online, can't we just enroll everybody who qualifies to do a BSc at UCT? That's not possible for a science degree, because we also have lab work, which has got limitations in terms of capacity. But it's also important that the students that we enroll are given the opportunity to flourish within the labs, in the field work that we organize, and these impose some limitations on the number of students that we can. My name is on the screen, so I don't have to introduce myself again. I will introduce members of the team when they have to help with some of the answers, if there will be a need for that. So we want to give you an overview of the science faculty. And just to give you a sense of what we do in the science faculty and what your daughters and sons will be doing as first years and in the years to come, so that you have got a sense of the activities that we're going to involve your daughters and sons. And it's important perhaps just to say that we pay particular attention to the first year students for various reasons. And some of them are that these are students who are coming to a university which is a different environment, and they need much guidance from the science faculty. And we have a team that has been assisting students, our first year students, to understand some of these aspects or activities in the science faculty. But obviously one can't tell them everything on few days. They will learn most of these things as they go along. What we try to do is to help the students to fit into the environment. They bring with them a wealth of experience from their high schools, from their cities, from their towns and the villages. And we think that this is a resource. It makes us as a science faculty to have a very diverse background and to use that to improve on our relationships with students, to broaden our knowledge using what the students know. We have moved away from the idea that the students are here and they know nothing. We have got to teach them from scratch. They are bringing something with them, and we need to build on that. And of course, you as parents are also playing a role. You have already played a role, thankfully, to get your daughters and sons to go through high school. And we think that that role should continue. So just to emphasize that I'm going to give you this overview, and thereafter we can have question and answers. So you can try to write the questions down so that when we come to that point, you will be able to. I see some hand in here. Shaman, could you check on that?
Would you
Maybe.
like to take the question now, or can we ask that Jane just hang on to the question until the question and answer section?
Maybe this, yeah, until the question and answer section, Jane,
Okay.
we will attend to that, just to be able to manage time. Some of the questions that parents might have could be answered as we go through the presentations. If that's fine, Jane. Thank you for raising the hand, and we will come back to you. In the next slides, I want to give you a sense of what we try to do in the first instance in science is to remind the students in their first years what science is all about, but also to try and encourage them to think about science in a broader sense. We all know that science is something that's characterized by wonder. And how one creates wonder it's through different ways. So when we take them to field work, when we put them in the labs, we want them to see what is in the world, and to begin to want to answer those questions. If they see um, different forms of life, for example, they have got to try and understand what makes that life different from the one we have as human beings. We have to make them to want to answer questions about the observations that they make. It could be, the stars that are falling from the sky. They need to understand why this is so. It could be the flaws in society that we see happening. It could be the heat waves. It could be the viruses that have hit us, and we want them to try and be creative um, in answering those questions. So the first prize in science in the faculty is to create that sense of wonder. Why are things the way they are? Why do things have the shape that they have taken? Why do um, why did the world look the way it is, especially the physical features, but how those physical features also relate to society. And so we cultivate that sense of wonder, hoping that it is through that sense of wonder that we can have more creativity. Um, Creativity cannot be taught easily by just getting students into the lecture theaters and teach them the subjects. We need to instill in them the sense of being creative by themselves, how they want to grapple with things by themselves. More importantly, in this day and age, we want our students to understand the world around them. The world throws at us so many other questions that we haven't been able to answer. And some of the questions have been there for generations of scientists to grapple with, and they have not been answered. And what we try to do now is to make them understand the world and the questions that arise from that understanding, so that they can grow up as scientists. And that should start from the first year, in order to get them encouraged to continue to seek answers. But they have to be given the chance to work things out themselves, to be able to suggest what could be the solutions to the problems that they see, to grapple with the societal challenges that we see, um, or societal challenges around us, societal challenges around the world, so that they can use their scientific understanding to try and solve these problems. So in some ways, we take an approach that enables students to think about some of the problems from a scientific point of view. And this is why they've come to science, and try and see whether they can go through these puzzles and get the answers. In many of these questions, there aren't answers, but they are useful for creativity, for engaging with the students. These questions and the problems we seek to solve allow the students and professors to have something to interact on, to have something to engage with, because that's important for them. But we have to ask the question about what is the purpose of science? What is the ultimate goal of science? In many ways, science has to help us improve the quality of life of people. And it has done so over many years. Today, we don't worry much about darkness because we've got electricity, as an example. Um, we in Cape Town, and I realize most of you come from Cape Town, we were facing one of the most challenging problem of water shortage, for example, which would have made the quality of life deteriorate for many in the Western Cape. But how do we use science to improve the quality of life? And that's the question that our students will need to grapple with. In addition to passing the courses and getting good marks, what we're hoping they will do at the end of their career is to be able to contribute in improving the quality of life. So that's quite important for us. But how do we get them interested? And as we'll see next, we have to find a way of taking the students to society. Um, we have students who come from different backgrounds, and some of the challenges of society might not be very clear to everyone. So what we try to do then is to take the students to places, to sites where they can begin to understand some of the problems that society is grappling with, so that they can think about using scientific approaches to solving those problems. And one example which you have on the screen now, it's taking students to the streets where they interact with members of the public in what is generally described as public service. But we don't use that, just to provide public service. We want to use that as a form of the co-production of knowledge, where the students will engage with members of society who will be able to explain the kind of problems that they have, for example. And in that way, the students can not just imagine the problems, but they face the problems squarely. And so this is just one example that we have. The second example, which we have, it's dealing with some of the problems, not perhaps to solve the problems per se, but also to create some passion for scientific discovery. And so when we have got a problem that a section of society is grappling with, for instance, stormwater, which is always a big problem whenever you have got heavy rains, which is a big problem when you have got old infrastructure, which cannot cope with the demands of the 21st century. Settlements have grown big, and there are huge demands on the infrastructures that were built sometimes for a very small population. And all these things can be magnified by stormwater problems. And here is an example of the Lisbiak River, which is just across the road from UCT. And to get students to begin to think about stormwater not just as a study about water and the flow of water from point A to point B and what happens in between, but to begin to imagine these stormwater problems as symptomatic of the bigger problems that we have, as an indication of the changes that we have had as a society, so that they can begin to ask different questions, and that's important. And in the next example it's more about, in the next slide we see how we need to take science to the high schools. Of course, the pandemic has disrupted this effort, where we need to take our students to the schools so that they can at least be exposed to some of the scientific thinking. And in this case, we had Stephen Hawking, who all scientists would know was one of the most innovative person in the scientific field. But to try and get those ideas to high schools, you need students from the university who want to move out of the ivory tower and get involved in the school education. And the science faculty has tried to do this with teachers. We have done this with the students themselves, or learners, as some will call them. And this was simply an idea that we need to bring science to the high schools, because we also feel that some of the schools don't have facilities. And as a matter of fact, we do bring some of the schools to campuses, to our campus, to our labs, to see what we have, hoping that they will be inspired to want to pursue science. But COVID has really dampened the spirit of going to these places, because we had to observe the protocols. For the past 2 years, we have been unable to do any of these, and that's very unfortunate, because it is important that as students we need to have We need to have students who are not only thinking about themselves and their own futures, but to begin to think of the futures of others in terms of scientific fields. How do we get students interested in mathematics, for example, in physics, in chemistry from early on, so that we inspire them to come to UCT one day? And we don't necessarily do this to create feeder schools, but to help the communities to acquire the skills that they need. So I can go on to give more of these examples, but I just thought I would share this with you about how we involve students in the broader society. But in order for them to do this, they need to have the background knowledge of the disciplines, and that's where we come to now. It's the kind of disciplines that we offer at UCT. In many science faculties in the country and abroad, they are key subjects that faculties of science would offer, and we do have most of these subjects. What we have done, and the orientation has helped your daughters in science to understand what majors are, and I'm just going to briefly take you through this. And these majors, we have 20 majors in the science faculty. I'm going to explain later on, how these work in the sort of real situation when the students have to begin to attend classes. But we have grouped these majors into three categories or clusters. We have the biology, earth, and environmental sciences being put together. And the reason for this clustering is to get students to do the subjects that are very much related, subjects that will reinforce their knowledge, subjects that will allow them to have a broader understanding of what they are studying. So instead of allowing students to take very disparate subjects that are far apart, we try to encourage them to do the subject that will reinforce their knowledge so that they have got a solid background. So one of the classes is in the earth-related sciences, for example. Students who are interested in understanding earth-related subjects, we encourage them to take that cluster. The second one is chemical and molecular sciences. And even in that cluster, you have got things that are related, and I'm going to come to this. In the next slides, you will see how we cluster these majors. So we go to the biology, earth, and environmental sciences, for example, and that's why you have got 7 majors. Some of the subjects are not related to what high school offers. And they even have different names, which might be confusing at first to students who haven't had any chance of even studying this or reading material on this subject. So we have archaeology, and as we know, archaeology is an earth-related science. Students have to go back to many years of development in many areas of life to try and understand what has happened before us, for example. And I'm not going to explain each of these subjects. So if you look at this grouping of subjects or majors, you will see that they are related in some ways. They help students to have a better grounding of how the Earth in its broader sense is constituted, how it works, and the challenges that we face from this subject. So these 7 majors, they don't have to do them all. I'm going to show you how we structure these majors, and during orientation, your daughters and sons have been have been taken through all these majors so that they can understand the choices that they need to make. Because these choices are important, and as I will show in a minute, it is important for the students at first year level to have a better grasp of what they're going to study, because the majors will be there for some time, and they've got implications on how long they will take to complete the degree. I'll come back to that point because it is quite important. The next cluster has to do with the chemical, molecular, and cellular sciences, and this will be your biochemistry, chemistry, genetics, human anatomy, and physiology. And I'm maybe this cluster needs to be understood in the context of how it relates to many other aspects of well, many other courses and also other faculties. So human anatomy, for instance, it's in the science faculty, but is taught by colleagues who are in the health sciences. And one of the questions that students ask every year, and I will also say parents ask every year, is how to do science, a BSc, and then move to to the health sciences. And that's always a very tricky situation because there's no guarantee that if you do this, you will go there. What has happened, though, is that students who are very much interested in the possibilities of pursuing the health sciences, they have done some of the subjects that are also offered by the health sciences, and human anatomy will be one of them. But it doesn't guarantee that they will go into the health sciences when they do their second year. What it does is to give students some sense of whether this is where they want to go, because they are aspirations that come from the students themselves, and parents also have aspirations about where their daughters and sons should go, and their careers and their possible future. And so this is the cluster which the students who have got interest, who have some interest in the health related fields have tried to do. But as I said, it's important to note that there's no guarantee that if one does this, one will end up in the health sciences. But it does offer students at least some courses which will help them to know whether this is the area, the field they want to pursue, whether this is the career they want to pursue. So we have got 4 majors, and most of these majors will have limitations, because of the space, because of the labs. So there are limited numbers of students who we can take, and these will be usually the top students. Who should first be admitted to the science faculty, and then they can choose the majors. And I think that's important to emphasize, that students have to be admitted to the science faculty first, and then they can decide on these majors. But some of these majors have got other limitations, in the sense that they might be looking for even higher scores in terms of students' performance. For example, in cell in molecular and cell biology, we have to have limitations because of the laboratories. I just thought I need to emphasize this point because it comes up every year about I want to do this, and we know that students at times make a choice of going to to medicine as the first choice, and the second choice is to come to science. Not all the time, but where this happens, we sense that students want to come to science as to get the background in order to go to a different field. And there's nothing wrong with that. We just need to understand how it works. And I'll be happy to explain this more if there are questions related to this. So the next group of clusters are the quantitative fields, where we have brought this together. Astrophysics has benefited from the national infrastructure on the SKAs, the big stereoscopes, and many other things that are of a national importance. I'm sure some of you would remember that South Africa had to bid to host some of these big this big infrastructure in order to study the stars. And as a university, we've benefited from that investment. And I think the quantitative fields and the majors are meant to give those students who are very much strong in these quantitative fields to pursue them, to have a career, to build a career on quantitative uh, studies. And we also have some compulsory majors here, which you could see on the screen. So if somebody wants to do business computing, they also have to do computer science, for example, or computer engineering. They've got to do computer science, which is in the science faculty. So um, as we know, in the 21st century, computing is becoming the big thing, both in industry and in society in general. And there is a huge demand for some of these. And this is an area where in the science faculty we also have large classes, because there are more students who want to do this. But it is also something that we offer as a science degree, to give all our students a better grounding in science. And that is why even in the admissions, we have got math and physics, for example, as subjects that students who have done well in them stand a better chance of coming to the science faculty. Because we see this as a good foundation for students to pursue science. Let me try and explain in the next slide about how we, how these some of these facilities that appear distant are actually on campus. So we have this. It's actually one of the investment we made was just to ensure that students who are studying in astrophysics, in astronomy, will have some of these facilities on campus. And we do bring students also to come and see the stars, hoping that we can inspire them to be to follow astronomy or astrophysics in their field. And so these are just some of the things that we have on campus. But going back to going into the majors in the structure of the BSc is, I think this is where things become very, very important for both students and parents, because the way we've structured our BSc degree will determine whether the student is succeeding, how many more years the student will take. We've got a 3-year BSc degree program, and we hope that in the first year, the students will be able to do 4 first-year courses, including the majors. So, and this is where it is important to have a good choice of the majors, because the major is a subject that they would do um, from first year to second year to third year. You could be asking questions about why do we have many subjects in the first year and they get fewer as they progress through the years. I mean, the reasoning behind this is that we give the first years a wider choice to test their abilities, to test their own interest, and to find their grounding. And the material is also such that we don't go too much into the depth of the subject, but to give them the background that they need to understand the material. So it's important to give students that latitude, the opportunity to see what is available and what is it that interests them. And this is what the university, at least, it's a very good space for the students, because they can make some of these choices. They can choose the major that they want to do for their degree. We have got some structures and rules to guide them on these majors, as we saw in the previous slide. You could have a major where you need another major in order to you need another subject rather in order to major in whatever you want to do. And so it's important, and for you as parents, to see how your daughters and sons are progressing through the years. Having done year one at the university, going to year two does not necessarily mean that the person is doing second year of the degree, because they could be repeating some of the courses at first year. We require them to have passed a number of courses in order to proceed to a second year level. So this becomes a bit tricky sometimes, because the students could be in their second year of study, in their second year at the university, but it's not necessarily a second year of study in the BSc degree, because maybe they haven't met some of the requirements. So that is something for parents to watch about the performance of the students. The key questions will be, are they passing their majors? Are they doing well in their majors? And these majors are not cast in stone. We have got four courses at year one, and any of those courses could be a potential major. And so if the students thought that they could major in say chemistry, and they realize they really don't like chemistry that much, they could go to another major in the second year, but they need to have passed these courses. And so sometimes students stay longer in the system because they haven't progressed with their majors. And without the majors, it becomes very difficult for the students to complete their degrees. So that's quite critical. And some of the majors might not appear very impressive to the parents. They might say, well, why didn't you major in this or that? There aren't majors that are the road to poverty, so to speak. That you've taken the wrong major, you will be nothing in life. I think students can always bounce back and be well established. So going to the next slide. Choosing the majors, and I want to end here so I can give you a chance to ask questions. Choosing the majors should be aligned with the interest of the student. I know that as parents, sometimes we wish students could do something, or they should do something that we would have been interested in ourselves, for example. But I think it's important to give students interest, students chance to have their interest flourishing in a degree, but also to allow students to pursue their talent, what they're gifted at. And at times, what the students want to do could be in line with the career that they want to follow. And there are many factors that come into play. So I think there should be some discussions about the majors and why students have taken the majors that they have. So in the next slide, I want to just say there are different career paths that students could follow, and this is just a sample of the career paths. I'm sure there are many other careers that students could have, and we have got a career service for the whole university that students can have some conversations about where they might go with the subjects that they have. And I want to move towards the conclusion now in the next slide, and give you the chance to ask questions and see if we will be able to answer them. So in a nutshell, this is what we have. I thought we'll give you a sense. And if you have got any questions, you can unmute yourself and ask the questions if you want to, or post it on the chat, and we will be able to try and answer the question. So I want to invite you to ask questions. Thank you very much. Thank you for attending this session. Now is a chance to ask questions.
Manu, while I make the changes, there are 2 or 3 questions in the chat.
Okay.
Would you like me to?
Could you read them for me? Yeah, thank you.
So Manu, the first, it's Pippin Anson here. The first comes from Gustav, and he says, how well prepared are our students for an international job market? Their interests might not be met here. And are we preparing for an international job market?
That's a very good question. Just last week, I had to sign off on the scholarship of our students who want to pursue postgraduate studies overseas. And every year we have got students who get that scholarship. The Sky Scholarship, that's the name of it's linked to some of the top universities in the UK, as far as I'm aware. And so we are convinced as a science faculty that our students are globally competitive. And they have gone out into the international market in their career choices, and they were able to compete favorably. And we want to keep that standard. So that will be my answer to that question. Pippin, thank you very much.
I have another one here, Manu. So Nelia wants to know, they say that they understand that passing these early courses towards majors is particularly difficult, especially reference to the MAN courses, those math courses. And the question is, what can we as parents do to assist? But also they ask, what does the faculty do to ensure that these students get through these courses?
Thank you. Yeah, that's really a very crucial question to grapple with. We have been working hard, especially in MAM, because MAM does not only impact on the BSc, it impacts on other faculties as well. So it has got a university-wide impact. What we have done in the science faculty is to try and understand what the impediments are, to understand what the challenges are. Is it the background from high school that students bring to UCT? Is it the curriculum at UCT that makes it difficult for students? Is it the way we teach mathematics? Or are we overloading students in the teaching of mathematics? And these are the questions we have grappled with for some time now. And we have structured some of the courses to try and address this. One of the things that we're doing as a result of COVID-19 was to think of other ways of teaching, because mathematics was not always easy to teach online, for example, and professors have to be trained to teach online, but that still is not satisfactory. What we are doing at the moment, and this year in particular, is to beef up our tutor program so that students can come in small groups and learn at their own times with the support of senior students. We call that peer learning because sometimes students are intimidated by the professors who seem to know everything, and they feel that they cannot cope with the material. So what we have done is to bring in their peers to assist them to learn. And that's a program that we are monitoring, and we are actually getting more and more of the tutors to help the students. This plan was interrupted by COVID because then we needed to sort of rethink everything. But now we're back into trying to get students. Even if we were to go to level, say 3, for example, we will still want these tutorials to be in person. And that's why we've invited our students to be back in Cape Town, so that we can have the opportunity to interact with them. I think we miss the interactions, and that has made the teaching of some of these subjects. It's not only mathematics, physics, for example. Students have not been able to come to their labs due to some of the regulations. But we need to move away from this online space in some of these subjects. And one way of doing that, even if we have got restrictions on the numbers, if students are in Cape Town, we should be able to bring them in small groups to interact with the professors, to interact with the senior students. Thanks, Pepin.
Maano, I've got another one here from Sean, who's obviously has a student who's signing up for computer science and computer engineering, but I think the question is relevant across the board. Sean wants to know about the suggestion that some programs should run over a 4-year period rather than 3 years. And I thought it might be useful to talk about our extended courses and how these work and the reasons for those courses.
Thanks, Pepin. So there are students. I mean, we admit top students in the country, and we are fortunate in that regard. But what happens when the student is not coping at the university? We don't think that they are not coping because they are not good students. We tend to think that is because of the load that they have. In some of the courses, the load could be bigger than what students could cope with. And so we do have a program that allows students to spread their load over 4 years. All our students start as a BSc, in a BSc program for 3 years. And when we have the test in the first term, we can see which students are not coping. And those tests, together with many other indicators that we have in the system, help us to talk to the students who might benefit by spreading the load over a longer period. And that's where some students end up with a 4-year degree, not by default, but as a strategy to try and help them to perform better in the subjects that they do. Of course, there's a worry about the finances. The parents would have budgeted for 3 years, and now there's another year to add to. But we also want to give students a chance to perform better by not having an overload. Because if they have an overload, it becomes a problem. Even if they are good, they will just have, they will just pass. Our pass mark is 50%, but with the 50%, you don't go any further. So it's a dead end. But if you spread the load, you give students the chance to do well in the subjects that they could perform well, and in the subjects that they can pursue. If they want to go to honors, they will be able to do this subject because they know it so well. But when that subject that they know so well, it's mixed with many other subjects that are overstressing the student. We can't even know what the student is best at. So that's one of the reasons. And we have the NEFSAS system, our our government funding system that has recognized that students can go to that 4-year degree as well. I hope that answers the question. I'll be able to take the next one.
Maano, there's a question from Nelio about WSP scoring and the mechanisms leading up to examinations. I'm not sure I know what WSP scoring is myself. I've asked for clarity. Maybe take a question off the floor and Nelio can come back to me with some weekly performance scoring. Do you have any response to that? The question is explicitly, could you provide us with an overview of the WSP scoring and what the mechanics leading up to examination are?
Yeah. So in some of the departments, they want to ensure that students have the basics as they go along, and they would monitor the performance by using this continuous assessment. Sometimes it's just quizzes that they've got to do every week. It became more important during the pandemic in order to ensure that the students are engaged with the material. Because when you don't see the students, you can't be sure whether they are learning or not. So you need to keep testing them so that they continuously engage with the material and you can be sure that they understand the material. It's also good for the professors to try and find out whether the material that they're presenting online, for example, it's something that the students have grasped. It's something that the students need help with, and so it is part of the assessment too. But it does help the students to keep engaged. But more importantly, for the professors to have a sense of whether the students are learning. So that's why. These are done in some of the subjects. I'm aware that there are departments that have got this weekly assessments, which then also feed into the course mark. The course mark being the overall performance of the student during the semester. So they used it as part of it. It does not replace the tests. It does not replace the examinations, but it does indicate whether the student is learning or not. And it also helps to understand the interventions that might be needed or required for that course. Thanks, Pepin. Is there another question?
Yeah, so Manu, there's some from the floor, and maybe Charmaine can help unmute microphones. There was a parent by the name of Malinga who had their hand up, and now they seem to have disappeared. So maybe Charmaine, if you could find that parent. Otherwise, there was Carrie Ann Diamond had a question, has their hand up.
Okay.
And you can just unmute your mic.
Yeah, if you could unmute your mic and ask the question.
Hi there. Yeah, my son it's actually more from my son's asked me to ask you. When will they be added to the classes that they have been assigned to? So they've obviously chosen all their subjects or their majors, and they haven't got their full timetable yet. And he's just asking when that's going to happen.
Okay, I think the team that is in the orientation here will help with that. Pepin, can you help with the answer to that question?
So Kira, my understanding is that the wheels will turn and the students will be allocated to their classes and will likely get access to the Vula sites. They're all now wonderfully digitally literate and they understand UCT's online platforms, and they will be added to the Vula sites, I would think definitely by the weekend. So what I suggest is that your son keeps an eye out. He can keep logging on to Vula and he can see if there are fresh tabs added. I'm delighted that he understands that is where he needs to go. It makes me feel like we've done our job well. And he will be added to the Vula site. So as his registration goes through, as long as he's hit that final enroll button, electronically, he will go through final sign-off from our advisors and faculty will process him, and he will appear on those Vula sites. He is always welcome to come back to any of our orientation leaders. Come Sunday night, if he still hasn't got anything, please do shout. But a degree of patience is probably what's required at this point.
Okay, talking about patients, and I know it's the last question. You mentioned NSFAS. I believe NSFAS is having some severe difficulties at the moment, and there's huge backlogs. No one really knows where they stand and their status. What's going to happen in terms of fees and things like that when we're still waiting for an outcome?
Yeah, and that's a very unfortunate situation we are in, because NSFAS is managed by government. And there isn't much we can do to manage that process. But what we do as a university, and NSFAS is managed at the university level, not at the faculty level, is that the students who have been awarded an NSFAS, and we have a list of, if we have a list of those students, we allow them to register, because we know that the government will have to pay. So it's almost like a student who have a bursary which hasn't arrived. As long as we have the guarantee that the student has been awarded a bursary, we will register that student, so that we don't have to wait for the money to arrive. So that's the approach that we take, so that the student is not waiting forever, because sometimes the NSFAS funds could be released quite late when we have when the year has already progressed. And so that's how we manage it. Thanks. I think Kerry had a hand up, but it has gone down now. Have you been answered, Kerry?
Yes, thanks. I've just chatted to you now. Thank you so much for your answers.
Okay, thanks. Pepin, do we have another question?
I don't have any more. Aquilina wanted to know what constitutes a distinction at UCT, and I've said 75% or above, is my understanding. I don't see any other hands, Manu. Are there any other questions?
Any other questions? We just have 1 minute to close the session, but we can take the last question. Okay, thank you very much. If there's no question, I really enjoyed the interactions. I hope you found the information we shared with you, the overview of the science faculty, useful, and so I really appreciate that. I'm not sure whether we're going to have any other session. Sean, I see your hand is up. You can unmute yourself, Sean, and if you want to say something.
Sorry, that was by mistake. Sorry. Thank you.
Oh, okay, that's fine. Okay, right. Thank you very much. Please do stay in touch with your daughters and sons, and find out how things are going. And if there's anything that you feel the faculty should be aware of as things develop, please do encourage your daughters and sons to approach the course conveners, the professors and the department, so that they can be of assistance. We cannot be a university, we cannot be a faculty without the students, and so they do matter. And we really again want to thank you, the parents, for choosing the science faculty at UCT. Have a wonderful afternoon.